Hi everybody, welcome to PHOT 1064 week 4. So this is the second video for week 4, and in this video I'm going to be talking about polarizing filters or polarizer filters, and also talking about um, just polarized light and how does light become polarized, and as photographers, why do we even care? What does it have to do with us? Well, I guess the answer to the first question is, why do we care about these guys? Why would anybody want to use one of these polarizing filters? Well, if you take a look at this image here, we're looking at two photos of, I guess, a beach and the ocean. And the picture on the left, you can see the water looks very light blue, very faded, kind of washed out because it's reflecting so much of the sky. Whereas the photo on the right, the photographer has used a polarizing filter, and they've blocked out the reflection on the water so that now we can see the true color of the water. It's this deep saturated color, and we can even see through the water so that we can see what's underneath the surface, so at least see it a lot better. I'll also draw your attention to the fact that while the water has gotten darker, the beach has not changed. It is the same brightness in both photographs. Well, isn't that interesting? In this photo here, we see a model. She's inside of a car, and the window is closed on the car. And when you look at the top image, you can see there must be a woman who is standing nearby, and we can see her reflection in the glass, and there's some other reflections obscuring the model's face. And on the bottom photo, the photographer again has used a polarizing filter. So what has that done? Well, it's removed the reflections from the window. So that is what the polarizing filter is doing for us. So I could end that video right here, but since it is a science and theory class, we should talk a little bit about how that all works, and how is it that polarizing filters can remove reflections. So to get this topic started, we should think back to the previous video where I talked about white balance and color temperature, and in that previous video I talked about how light travels in waves, and so that's kind of the tie-in. That's why this topic is in week 4. But anyways, light travels in a wave formation. Okay, well, we learned that in the other video. But one thing that you should know, and I just want to get across, I'm actually going to back up here, is know that, yes, light travels in waves, but it doesn't necessarily travel up and down. In fact, some light might be vibrating side to side. Some of it is vibrating on an angle. So if my hand was light coming towards you, it could be vibrating this way, but it could also be vibrating that way. It could be vibrating this way. So it's completely random what plane or what orientation it's vibrating in. All this light might be going in the same direction, but they're all vibrating in different orientations. Well, in that scenario, we would say that light is not polarized. It is unpolarized light, just random orientations. Once light is traveling all in one orientation, then we would call it polarized light. Give it the name polarized light. And if you take a look at this image here, imagine, if you will, we took all this light that was vibrating in a random orientation, and we put this filter or this polarizer in front of it, and think of it as, well, a filter. So what it's doing is it's filtering out all the light that is going in an orientation that does not match with that slit that's in the filter. So the only light that gets through is whatever light matches the same orientation as that opening in the filter. Well, on the other side of that filter, then, any light that passed through is all vibrating in the same direction. So the light on the right-hand side, we would say it is polarized light. So that's what polarized light is all about. This is one way that we can get polarized light, but there's other ways that we get polarized light, and we'll talk about that right now. So the first way that we context, or the first one way that we encounter polarized light, is any light that bounces off water molecules in the atmosphere or in the sky. So this diagram here is showing us light waves vibrating in different orientations coming from the sun. But when it hits these water molecules and bounces back towards Earth, it's now polarized. It's all bouncing, or it's all vibrating in the same direction. If you take a look at that filter, the image of the filter there, what it's showing us is that there's, I guess, slits or lines in the filter. And what those lines represent are the tiny little molecules inside that glass, inside filters like this, that are all oriented in a very specific direction so that only light vibrating a certain direction can get through. So if you take that filter and you turn it 90 degrees so that that slit or those lines are not lined up, not vibrating the same way that the light is, then we will block that light. So that is what polarizing filters are doing. They are blocking light that has been polarized. And the only way we can do that is if this also has slits in it. And you'll see later on that when you use a polarizing filter, you actually have to turn it on the lens while it's on your camera, and you turn it until you see the reflections disappear and reappear as you turn it. And you want to stop it once you can block out the reflections, or in this example, block out the sky. So when you use a polarizing filter, one thing you can do is make the sky darker. And the reason you could do that is because light bouncing off the water molecules is polarized. So there you can see an example of the picture on the left, kind of a washed out sky, very light blue. The photo on the right, the polarizing filter has darkened the sky and made the clouds more visible. I should point out too that this effect is stronger when you are 90 degrees to the sun. So instead of aiming your camera anywhere near the sun, turn your camera so that the your viewfinder or your sensor or your lens is 90 degrees to the sun, and you'll see the effect of this polarized light become stronger, and you'll see the sky turn darker blue. So this is a this is a picture I downloaded off the internet, and you can see what this photographer has done is they did sort of a panoramic shot and or stitched several photos together. And on the right, they're aimed almost at the sun, and you can see the sky doesn't get very dark at all. The polarizing filter has very little effect. But as we start getting further away from the sun, and the left-hand side of the photo is showing us 90 degrees from the sun, and you can see that the sky is starting to get very dark. So the polarizing filter has having a much greater effect because most of that light is polarized. Here's a couple of other examples just so you can see how it can change your photographs. Here's without a filter, here's with a filter. And you can see that the building itself doesn't really get any brighter or darker, it's just the sky that's changing. Here's another example. This was taken on one of our field trips a couple of years ago, and you can, if you look at the sky, it's kind of a faded blue, and if you go to the second photo, the sky's darker. We can see the clouds stand out a little bit more. Notice when I switch between the two photographs, though, the student's shirt and the camera bag and the dirt doesn't get any darker or brighter. It's only the sky. You might also notice that the leaves actually look a little bit deeper, a little bit more saturated, because the polarizing filter is taking out some of the reflections on the leaves, which is another good use for the polarizing filters when you're doing landscape photography. Another way, so that's the sky light bouncing off water molecules in the sky. The other way that light can become polarized is when it bounces off a reflective surface like glass or any glossy surface. Could be paint, plastic, water is another example of a reflective surface. So here's a picture of me, again taken while we were on one of our field trips, and something in the window here has caught my eye, and I thought, oh, I'm going to take a picture. It looks kind of neat. And when I aim my camera at the window, whatever it is I'm looking at there, oops, I'll jump ahead here, all I can see, so I'm trying to take a picture of those hats, but all I can see are reflections of people in the glass, and I can see cars being reflected in the glass. So what I've done is, and I'll jump to this picture here, I put a polarizing filter on my lens, and I've got my fingers on there, and I'm actually rotating the lens, or sorry, I'm rotating the filter, and if I move this a bit closer, you might be able to see that there's a part of this filter that actually rotates, and that is, as you rotate it, the effectiveness of this polarizer gets stronger and then weaker. And you just got to find the perfect alignment where it blocks as much of the reflections as possible. So there's my first photo, and then there's my second photo with most of the reflections removed from the window. I should also mention too that in order for polarizing filters to work, you have to be at a very specific angle. And in this case, this diagram is showing us 35 degrees, and that's the ideal angle to maximize the ability for this filter to block out the reflections. As you start getting closer to 90 degrees to the glass or to the glossy surface or reflective surface, you'll see that the polarizing filter has less and less effect. So there's a special angle. It's actually called Brewster's angle. I don't think we have to worry about that as photographers, but there you go. Just wanted to point out that just being, I can't go right in front of the glass and aim directly into it. I have to be on an angle in order for the effect to work. Here's a third way that light can become polarized. There are certain crystals that will cause light to be polarized. So tourmaline crystals is a natural forming crystal. And in a lot of ways, this crystal is just like this polarizing filter in that it has molecules in it that are aligned a certain way. And it will only allow light to go through that as a certain orientation. So on the other side of this filter, if you were to shine light through on the other side, the light would be polarized. So 3 ways that light can be polarized. Reflections off water molecules in the sky, shiny surfaces, and or reflective surfaces, and through some natural crystals. So good thing to know for your test. Polarized light. Polarizing filters. There's 2 types of filters out there, linear and circular. And when we say circular, we don't mean the shape of the lens. It has nothing to do with the fact that this lens is round. It's just that there's something in the filter that takes that polarized light that's coming out the other side and unpolarizes it so that your sensors in your camera can use that light. If you just use an old-fashioned linear, and in fact this filter is actually an old-fashioned filter, it just happens to be what I had in my drawer in my office. This filter, if I were to put it on a DSLR camera, it'll still work and all that kind of stuff, but the auto exposure might be thrown off. I might get inaccurate exposure readings because the light coming on the other coming from one side of this filter to the other is also polarized, and the sensor on the camera, the sensors, there's things called beam splitters, for example, inside your camera that they need random light. They can't have polarized light. They don't quite work. They're not designed for that type of light, and they start producing inaccurate readings. So there are specific types of filters that you need to get, and they're called circular. Actually, I'm going to go to a website here. This is Vistech. That's one of those stores in Toronto where you can go to buy photographic equipment, and they sell all kinds of filters. So does Henry's. So does just about any other camera store. And I just pulled this up just randomly just to show you. So if you take a look at this particular filter, first thing you'll notice is, wow, it's $160. Wow. But what I want you to really notice is that it says right here CPL, circular polarizer filter. So what does that mean? It means it's a special type of filter that is designed for DSLR cameras like yours. In fact, all filters that you buy today will be circular, or polarizing filters rather, will be circular polarizers. The only reason I even mention linear polarizing filters is because you might buy a camera at a yard sale, garage sale, at a used store, or an antique camera store, and maybe that camera will include a filter, a polarizing filter. And if it's a really old filter, it might be a linear filter, and you won't recognize it. It won't look, it'll look just like this one and look like any other polarizing filter. But when you go to use it, you might find unusual behaviors with your auto exposure in your camera. Anyways, that's about all I really want to say about polarized filters. There is a link here on this that I'm showing on the screen now. It'll take you to a website where there's a guy who talks about the difference between linear and circular polarizing filters. I don't think you really need to know that. What you really need to do is get yourself down a photo lens and borrow one of these lenses, or sorry, borrow one of these filters and try it out. Just go there and they have different sizes. See what size your lens requires, and borrow one and go take some pictures and just see what it does and how it changes your photographs. You might be quite surprised. And that's it for polarizing filters. If you have any questions, please send me an email or come and see me in my office. My door's almost always open, just waiting for people to come in and ask questions. Anyways, hope you guys have fun. Those of you who are going on the field trip, I hope you guys have fun in Toronto and at the Pinery, and hope you're looking forward to it. We certainly are. Anyways, goodbye for now.